Today we're going to be talking about complex numbers. By the end of this lesson, you should be able to add, subtract, multiply, and divide complex numbers. So, what is a complex number? Well, in Algebra 1, we could not take the square root of a negative number. If you remember when we had the square root of negative 25, we just told them no solution. In Algebra 2 now, we can take the square root of a negative number using these complex numbers, or what we call imaginary numbers. Remember, all the other numbers we called real numbers, so I guess it makes sense that we call these numbers imaginary. And the way we denote these quote-unquote imaginary numbers is using the cursive lowercase letter I. So the square root of negative 1 equals I. The square root of negative 1 equals I. So let's see how. If I have the square root of negative 25, that is the same thing as the square root of negative 1 times the square root of 25. And I just said before, the square root of negative 1 is I, and the square root of 25 is 5. So we get 5i. So how about this one? So the square root of negative 32 is the square root of negative 1 and the square root of 32. And then the square root of 32 is the same as 4 and 8. And the square root of 8 is the same as 4 and 2. So I have a pair of 4's right here that goes on the outside. The square root of negative 1 is I, and then I still have the square root of 2 underneath. Let's talk about the square root of 50. So 50 is negative 1 and 50, and then it's 2 times 25, and 25 is 5 and 5. So here's a pair of 5's. 5 goes on the outside. The square root of negative 1 is I, and then the 2 stays underneath. Okay, now that we know where these complex numbers come from, now let's talk about the operations we need to be able to know how to do by the end of this lecture. When we add complex numbers, we combine like terms, like that I is a variable. When we subtract, same thing, we're going to combine like terms. But we're also going to change subtraction to addition and change all the signs to the right. When we multiply, we're going to distribute or use FOIL, depending on what the complex numbers look like. And then finally, just like how we did yesterday, when we divide or when we have a fraction, we're going to rationalize the denominator. In standard form of a complex number is the number part comes first, and then either the plus or minus, and then the I part with the number in front goes second. So this is how we want all of our answers to look after we're done with each problem. Okay, let's see how it works. So remember, the first thing to do is identify which operation we're working with. So in this case, we're working with addition. Each one of those says addition. So we just combine like terms. 1 plus 2 is 3. I plus 3i is 4i. Just like we would combine like terms if that I was a variable. The second problem. 4 plus 2 is 6, and negative 3i, well, let me erase some of that, it's kind of in the way. Okay, and negative 3i plus negative 2i gives us negative 5i. We are just combining like terms when we add and subtract. So for the last one, 3 times 4 is 7, and 3i plus negative 3i is 0, so we don't have to write the I on that one. Now let's try subtraction. So remember with subtraction, when we did polynomials in Algebra 1, we could line them up and then subtract them that way. Or we change subtraction to addition and change the signs to the right of the subtraction sign. And then we add like it's addition. 1 plus negative 2 is negative 1. And I and negative 3i gives you negative 2i. So in the next one, again, change it to addition and change the signs to the right. 2 plus negative 4 is negative 2. Negative 3i plus positive 2i is negative I, or negative 1i. You try the last one. Pause and try the last one. Okay, let's see if you're right. So we changed the subtraction to addition, change all the signs to the right. 3 plus negative 4 is negative 1. 3i plus positive 3i is positive 6i. Now let's see about multiplication. So remember I said with multiplication we're going to distribute or FOIL depending on what it looks like. If we look at the first one, that requires us just to FOIL, or sorry, distribute. 2i times 3 is 6i. 2i times negative 2i is negative 4i squared. And now here comes the new part. I squared is negative 1 because if I is equal to the square root of negative 1 and I square this, when I square this it gets rid of the square root sign, so I end up with just a negative 1. So if I plug in negative 1 in for I squared, that's going to change this part to be a positive 4. And then 6i is already positive. Remember, standard form, number comes first, I comes second. Now if we look at the next one, we have to FOIL that thing out or use the box method to FOIL it out. So let's say I want to use the box method. I have 1 plus I over here, and then I have 2 plus 3i over here. 2 times 1 is 2. 2 times I is 2i. 3i times 1 is 3i. And 3i times I is 3i squared. We combine like terms here. 3i and 2i is 5i. And then here, I squared is negative 1, so that makes this bottom right-hand corner negative 3. So 2 minus 3 is negative 1, plus 5i squared. Now pause and try the next two. Okay, let's see if you're right. This one I'm going to show you FOIL. So 2 times 4 is 8. 2 times negative 2i is negative 4i. Negative 3i times 4 is minus 12i. Negative 3i times negative 2 is positive 6i squared. So now we combine like terms. Negative 4i and negative 12i is negative 16i. This I squared is negative 1, so that makes that negative 6. So 8 minus 6 is 2. So we get 2 minus 16i. The last one, if we FOIL it out, I will use the box for this one. Let's erase some of this. Let's not do that. Okay, so let's FOIL this one out. I was going to use the box, but I don't have enough room. So 3 times 4 is 12. 3 times negative 3i is minus 9i. 3i times 4 is plus 12i. And 3i and negative 3i is negative 9i squared. So I combine like terms here. Negative 9i plus 12i is positive 3i. This I squared makes this positive 9. So 12 plus 9 is 21. Okay, let's look. So with division, it's very similar to the rational expressions we had the day before. We need to make sure that the denominator does not have an I in it. So again, I multiply it by the conjugate, which is 1 plus 4i. And then I FOIL out the top. So when I FOIL out the top, 7 times 1 is 7. 7 times 4i is 28i. 5i and 1 is 5i. 5i and 4i is plus 20i squared. The denominator, 1 times 1 is 1. 1 times 4i is 4i. Negative 4i times 1 is minus 4i. And negative 4i times positive 4i is negative 16i squared. Now we combine like terms. Like terms here, that makes that 33i. This I squared makes this negative 20. So 7 minus 20 is negative 13. These cancel. And this I squared makes this positive 16. So 1 plus 16 is 17. Then I look at the triangle. And I see if they're divisible by the same number, and they're not, so we keep our answer like this. You try the next one. Okay, with this one, let's rationalize the denominator by multiplying the top and bottom by 1 minus I. And on the top, we just distribute, and we get 5 minus 5I. And on the bottom, we FOIL. 1 times 1 is 1. 1 times negative I is negative I times 1 is plus I, and then I times negative I is negative I squared. Notice in all these, the middle cancels just like with the square root, so we don't necessarily have to write it. This I squared turns out to be positive 1, so we get 5 minus 5I, and then 1 plus 1, so that's 5 plus 5I all over 2. And those three numbers are not divisible by anything, so we leave it like that. Okay, you pause the video and try this one. Okay, let's see if you're right. So we multiply the top and bottom by the conjugate, which is 3 plus 2I. And we FOIL everything out. So if I multiply the top, 5 times 3 is 15. 5 times 2 is plus 10I. 2I times 3 is 6I. And 2I times 2I is plus 4I squared. In the bottom, 3 times 3 is 9. 3 times 2I is 6I. 2I times 3 is minus 6I. Negative 2I plus 2I is negative 4I squared. Combine like terms here and here. So we get 15 plus 16I. This I squared turns out to be negative. This I squared turns out to be positive, so 9 plus 4 on the bottom. Combine like terms here. So we get 11 plus 16I all over 9 plus 4, which is 13. And those three numbers are not divisible by the same number, so we leave it like that. Homework for tonight is page 66, 10 through 24, and we'll correct it tomorrow during class.